Hey everybody, I hope you're all having a great day so far, and I hope your Halloween was really good. Unfortunately, I got pretty rained out on Halloween, but it still wasn't too bad. We had quite a bit of people come by, so it's always fun. But let's go ahead and get started. I am a bit late because I had to restart my computer just before streaming, but that's okay. So we're working on trying to make a nice map now for the Tactical Lizard Tamer. We've had kind of a Minecraft style hexagon map, which is fine, but it's not really the style I want. So I'm working on making basically a flat mesh that will be able to like smoothly blend between the different tile types and both blend in elevation and color and texture, and so I think it should be really nice when we get everything done. It'll probably be a few weeks until then, but in no rush. So far we've gotten so that we create the mesh, and actually, oh well no, we've got the code ready to create the mesh, but we don't generate this blueprint yet, and this is like the in-between between the actual game data and the different mesh generators. And so let's go ahead and figure that out now. And my goal is for the mesh generators to only rely on data inside the mesh blueprint and nothing outside of that. So yeah, I have this. So here we basically just need to build a new blueprint. Well, thank you, Radeon. I'm good for now. And let's see. Let's create a new one. And since the mesh blueprint is just purely a data class, I've just have public variables here that will be okay. And so the row size we know from the board is just the row size here. And so far we don't care about the layer size, but I guess we will. So now what we need to do is loop through every row and or every tile on the row and column to find the elevation of the surface. And since right now our map is a simple one layer flat map, everything should just return 0, which is fine. Oh yeah, so I need to, it won't compile right now. So let's do something like for int column less than battle board. Okay. So the number of columns is the row size. And then the number of rows is the battle. Let's get, I always try to set a rule that if I ever have to reference an inner variable more than once, I pull it out like that. This helps keep things cleaner. Okay, so the number of rows is the board layer size divided by the row size. 0 r less than rows, r plus plus. Okay, so now we just need to find the surface for each of these sections. But actually, we don't even really need to know that right now because we're just going to create the cells. I guess since I'm already almost the way here, let's just have like an elevation variable here. The mesh builder won't actually use it yet, but we've already gotten this far, so we might as well fill in that data. Okay, so blueprint, cells, add cell, and the elevation here will be surface get layer, column row. Alright. No semicolons. And then of course I need to create this list. And then the last thing I need is the hexagon radius, which is just 1 for now. Yeah, so this should probably just be the radius. Okay, yeah, so this would be blueprint, hex radius. And then I guess I might as well just make height step or something. That's the height of one hexagon. Although we don't actually care about that yet. Okay, so now we create this blueprint. So yeah, this is not what we want. So terrain mesh. We want to create public void generate function. I don't think anything will be passed right away. So here we don't have a reference to the blueprint builder. I don't know if we'll need to keep something around, so I'll just create it right here. Okay, and then we'll have the mesh blueprint. Oops, if I can spell it right. And then we'll need the graphics mesh generator. And we just need to pass it the graphics mesh, and then call the graphics generator generate, and we just pass it the blueprint. Okay, so there we go, and now I just need to call this generate function. Oh yeah, nothing even called setup yet. Where's the class that hooks up the mesh into the object? Yeah, so here I might as well just reuse this class for now. Obviously, we won't want to keep the code working this way forever, because we'll want to call this in the loading scene, but for now this will be fine. This is the battle, I think. Okay, and then I just need to call generate. And that should take care of all that. So hopefully when we start the game we'll see a nice mesh. I guess I should get rid of this so we won't have double up. Okay, so there's an error first. Okay, saying the... Oh, okay. The problem is that when we start the scene, which is when this function is called, that's before... Or wait, this function is called as before the game has actually loaded everything. So how should I deal with this? Maybe I'll just insert something during the map generation phase. I'm trying to figure out what would be the best time. Well, you'd want to do it after everything is done, so probably right here. That's not what I want. I want to find, okay, the battle data verifier. It's the class I want. And this probably isn't the right place technically either, because it's like, this is just supposed to verify if everything is working okay, so this part shouldn't ever cause any errors, so it can technically go after everything is done. So it'd be right, probably in between here is when we'd want to actually do it. But I don't really want to spend too long fixing that, so let's see. So fix up loading. And to correct phase. So I guess once we get the basics down, we'll fix that up before we get into more complicated things that will require loading more assets and everything. Okay, so anyway, here when it's done, we'll just insert. It's gonna be a little annoying because this class doesn't have access to the game data or the battle. So let's leave it like that, and then we have the terrain mesh. Oops, I didn't want to do that. That's what I was trying to avoid happening. Okay, so now I just need to get these components. I guess I don't need to store the battle and game data because I can just pass them right when we get this train set up. And controller, component, data, battle. Okay, and then down here, right after check info, just add terrain, generate, add some extra spaces so it'll be easy for me to see where to come back and fix this, and hopefully that should be good. Okay, so nothing is there. Okay, so the terrain has 0 vertices. That's a bit strange to me. Okay, so let's clean up this a bit. So there's a couple things. Either the blueprint is not generated correctly, or something is wrong with the actual mesh generator. So I guess let's check how many entries are in the blueprint. blueprint, cells count. Okay, so now we gotta go look through. Option complete. Okay, so it said 25, and that's perfect because it's 5 by 5. But okay, so that means that the problem is in the mesh generator and not the blueprint generator. Oh, obviously we create the triangles and vertices, but we don't actually add them to the mesh. And so mesh vertices is vertices to array, and then mesh triangles. Okay. Okay, so it's still not showing up. Oh, of course, it's oriented, yeah, with Y facing up. It also seems like I got the winding backwards, which is a bit annoying. Okay, but let's fix the rotation wrong. I mean, the rotation first. All we have to do is change it, obviously, so Y faces up and Z is backwards, so every time I do Y, I just need to switch it to Z. So I guess it would actually happen here, because the corner offset right now is on X and Y, and we need to change this to Z, I think. Or change that to the Z coordinate. And let's see how that works now. I think it will still be facing the wrong way, but... Okay, so now it's flat, but yeah, the winding is backwards because you can see it from the bottom. I think if we rotate the camera, okay, so let's see. I'm a little surprised about that, actually. I probably am thinking about this wrong. So I want 0 to be the top, and then it should go, to go clockwise, corner 1 would need to be here. So let's do a test, and if I just add the first triangle, let me see how that looks. Okay, and then we can look down from the bottom. Okay, so yeah, well, actually, since this is the bottom, on the top, well, no, it's still right. That's clockwise, isn't it? So this is the center, then point 1, point 2. Okay, well, whatever. So let's do the first two, just to make sure I'm not going crazy here. Oh, okay. So now we can see the center was here, actually. I was gonna say that's not what I expected, so it is going backwards, so I need to switch around the X coordinate to get it to work how I want. Okay, so it's this negative cosine. Should turn off that sun. Really? I thought if I did that, then this little icon would go away, but I guess not. Well, I can also just move this really far away because it is a directional light, so position doesn't matter. Okay. So now it looks like this is backwards too. Now I'm confused. Let's go back. And it's kind of working. But the gold monster is right on position 0, 0, so we know that's the center. We need to get these coordinates right, I think, before we do anything else. Okay, so I'm guessing this is vertices 0. Yeah, because cosine at 0 is 0, so we know the x isn't moved. So the x was correct before, it was the z that was backwards. So yeah, let's switch this and that. Probably has to do with me subtracting 90. Let's see if this will work right. I guess maybe I should have just added 90. But whatever. This gets the way I want it, and I want it to wind clockwise around. Okay, let's try that. Now I'm just curious. Trigonometry is always hard for me to wrap my head around without just trying out values. Okay, no, so this makes it go... Oops. Incorrect. Okay, so I'll just leave it the way I had it, because that's how I wanted it to work. Okay. So now we're ready to get the rest of the triangles. Oh wait, okay, it scared me there, but it's because I was looking from the bottom up. Okay, so now we can see that we've got a flat plane, but obviously the monsters are too high up, but I think that we should actually move them down, because this is at 0, but we'll wait until we complete some more work on here. And then if I change the to wireframe, we can see the vertices here. And it's hard to tell, well, I mean, I don't think there's any way that you can tell, but each of these vertices is doubled up because every hexagon doesn't share with its neighbors. So we should probably fix that, and I think an easy way to do it is just to have the hexagons only generate 3 sides. Okay, so let's get this back like that. So yeah, I think if every hexagon only generates these top 3, then there'll be no overlap, except for ones around the edge, of course. Am I thinking that correctly? I guess let's try it out and see. So, well, actually, see, we don't want, yeah, we can't, I mean, that way would technically work, except we do need to keep track of the vertices that are around the hexagon, like the numbers, their numbers, because we need to be able to add them to the triangle here. So maybe a better way would be if we numbered each vertex, then we could kind of... Oh no, that wouldn't work. Because later on, we're going to have a lot more vertices in the mesh. So we need a way for hexagons to share the meshes that are touching. Okay, so maybe the easiest way would be if we just have like a data class that keeps track of the corners for every hexagon, and then whenever a hexagon creates itself, it can just look at its neighbors to see what those numbers would be. Okay, so let's start with that. In the future, we might want to keep track of more than just the corner vertices, but for now I'll just leave it how it is, or with just corners. Okay, so I guess I can have just an array here. And this would be, I don't know, corners. And then we'll have a dictionary, integer to hex verts. Okay, and then so whenever we, oh yeah, I want to try and keep this consistent. That will always refer to one block as a cell instead of hexagon, because later on the shapes will be, they'll still be like hexagon based because that's how the game works, but there'll be a lot more than just the hexagon vertices. Okay, so here we triangulate the cell, and I guess here is where we would create this class. And this is just called once for every cell, so we don't have to like do a lookup to see if it's already been created. So I just go index equals, and this doesn't need to be a dictionary actually. If it's just if the integer is just a key, it can just be a list. Or even an array, because we might as well use a list so that way we can reuse these classes in the future. Okay, so we'll do safe set here, which is just a helper function that lets you be able to insert a value into a list at any point instead of only being able to add. Because normally if you try to do this, you might get an error if the list isn't big enough to hold this object at the specified index. Okay, so we don't really care about the position of the center. Okay, and I guess here is where we'd build the corner indexes, so let's see here. Okay, so index or corner 1 is just upwards, so let's see here. Which hexagon would share the corner with us to the top? Oh, I just wanted to get picture that I could see. Let's I just need to create this list, I think, and then that error will go away. Alright, so let's get rid of that canvas. So above us, like this is one row, and then the columns are diagonal. So if you're not on the top row, which that means that you have no neighbor, then this corner would actually be corner number 0, 1, 2, 3, 4, corner number 4 on the hexagon in your same column, one above you. So let's just try this out. Guess we can't really just easily loop through here because we're gonna have different math for every corner, I think. I wonder how much minimalizing vertices actually. Well, no, it will help, I think. I don't really know. I'm trying to think kind of a little bit in the future and see the best way that we'll want to do it. Because, like, obviously when we have hexagons that are at different heights, then we would maybe not want to join up with a specific vertice, or with the one that's at the height above us, because we'll have a hill downwards. Okay, but let's just go one step at a time, I think. I should lift this up. Okay, so the above vertice or vertex, which is at okay, let's do this vertex. Our corner 0 vertex is above. It's basically the same. Is corner 4 on hexagon above us. I need to create this array already. Did I make it? Yeah, it needs to be public. It's corners. And we'll have 6 values in there. I can see in the future that would maybe, I guess it depends how we do the cliffs and everything. Because probably actually how we'll do it is the corners will kind of, like, we'll only share corners with hexagons that are on the same level, and then because we'll have other geometry in between those corners if they're on a different elevation. So I think this will be okay. Let's just try this approach. Another way we could do it is maybe we create all the vertexes first and then we go back and triangulate everything. I kind of like that idea actually, because then we'll be able to just pull the vertices that we need instead of having to look up ones that are around us to see if somebody else has used it. Okay, so yeah, let's try that. Let's do 2 different passes. And basically how we'll do it, I think, is we'll make every vertex that's needed for the border of every hexagon. And then from there, oops, so yeah, since I paused or saved that, it had to recompile everything. Okay, so I guess the question is, how do I want to number these vertices? Maybe we can just kind of walk each corner and then do those, and then the top. Yeah, I think that'll be fine. Although for now, since there's no vertices in the middle of every line, I can actually just kind of do the top and bottom edges of each hexagon, and that will hit all the corners. So let's see here. There's I guess every hexagon has 2 unique corners plus 1 more for the very last one. And this is corner 4, 3, and 2. Okay, let's close that. And also if I well, I guess we still need to like create the positions for the vertices, but if I have like a oh no, that's not. I was trying to confuse myself because I thought that like we'd already know maybe the edges of each hexagon, but then if they're on different layers, then they'd still have extra edges. One thing that we could do is maybe just create everything, and then if we see that there's 2 hexagons on the same layer, then they merge. But then we'd have already created an extra vertice, so I don't know if that's a great idea. But I think doing it this way, where we take 1 pass and we make all the vertices, and then we go through and triangulate just to kind of keep them separate. Maybe that will help a little bit. I guess we'll still need to look at our neighbors and see which ones are on the same same elevation. I guess it also doesn't matter if we just did it how I was originally going to. Where we kind of just complete 1 hexagon and then move on, and then just find the vertices next to it if we need to. Okay, yeah, I keep going back and forth on this, but let's actually change this from triangulate to create cell. And then I'll probably switch out this, or extract this triangle creating code out into another function. Okay, so I guess the most important thing is we need to create or find the corner vertexes, and if one doesn't exist, then we need to actually create it. Okay, so yeah, let's go back to how I was doing this. So corner 0. I guess we'll need to know our column and row. Oops. Oh yeah, column. Maybe I'll just leave it col because that's how it's typed out in other places. So yeah, if we're on the top row, then we just need to create our own vertex. Actually, how it works is since we are generating from the bottom up, we just always create the top vertex. Zero is top. What's it not like about that? Oh, this is supposed to be the index, not the position. So let's make a helper function here, private int, add vertex, vector 2, position, and then it'll just be vertices add, position, and then we'll just return vertices count -1. Oops, okay, I still have that copied. One too many parentheses there. So yeah, we'll always create the top, because since we're generating top to bottom, that would be fine. So I think we can always create the first 3 corners. And it's the other ones we'll need to look backwards to see if it's already done. Okay, I'm just going to leave this code here. Oh, that's going to cause a problem actually, because I wanted to rerun the game so I could try and figure out which vertices I needed to look up. Okay, well, let's see. So I wish I could easily draw a little sketch here. Well, let's see. The graphics program takes so long to start up. Okay, nothing's wrong with paint. So we've got a nice hexagon here. So this is corner 0. Oh, let's put it inside. Not a great 2. And 3 and 4 and 5. So we can always create these because we generate basically upwards and to the right. And this one could be shared with a hexagon below us, so we need to go, yeah, so it'd be column -1, vertices 0. We need to check. Yeah, because this hexagon is C-1. So column row. Oh yeah, could have done this a little better. Okay, so now we've got another hexagon here. And this is vertex 0 for that hexagon, 1. Okay, and then this hexagon. So the columns are diagonal, but the rows go that way. So this is actually... Oh wait, yeah, this... Okay, I did this wrong again. It's the same column below us, it's a different row. So this is column and then row minus 1. And over here is column minus 1, but on the same row. And then this hexagon above us is both column minus 1 and row minus 1. Okay, so this is 0, 1, 2. Okay, and 0, 1, 2, and 3. But I guess I don't really need to look at this one because I can just get the shared corner from this one. Because I create these 3 always. This one I get from the column or the hexagon below. And then this one I can get from the one... I guess I need to check both of these for this one. I think. Well, no, because they'd both be generated before me, so it doesn't matter. But, okay, in case, yeah, we generate, like if this is row 0, then row minus 1 wouldn't exist, but column minus 1 would exist, so I need to prefer using this hexagon. Okay, so the only one I'd look down for is here, and then these two I'd use corners 1 and 2 from the hexagon to the left. Okay, so I hope that all made sense. Okay, so anyway, so column 3 we'll get from the one below us, but only if our row is greater than 1, or greater than or equal to 1. I guess the way I say that is if row is greater than 0, then storage corners 3 equals cell vertices. I want the little c version. Index, and to get the row below me we need to subtract the blueprint row size, and then I'd get corner, what was the number again? 1. Oops. And otherwise if we're row 0 we just need to create it ourselves. Okay, so this code isn't too bad. Before I was thinking it was going to be super messy. Okay, and then if column is greater than 0. Alright, so let's see. Okay, so if we're on the first column, or if column is 0 but row is greater than 0, then we actually need to get from below. Otherwise we just go to the left. So how do I... Yeah, so this one is the most complicated. So yeah, if column is greater than 0, I guess we'll prefer getting it from our hexagon to the left. And that is corners 1 as well. And then else if row is greater than 0, then we'll get it from the one below us, which and that's corner 0. Oops. And then otherwise we create it ourselves. And then the last one, we always get it from the hexagon to the left of us, if it exists, of course. And I think that is its corner 0, isn't it? No, corner 1. And this, yeah, that one was corner 2 actually. Okay, so I think did all this. And then here, instead of using this, so we should just call add vertex center. We don't really need that anymore. Oh, I guess I do need to keep track of the center. Center vertex, yeah. But what I need to do here, instead of just assuming this order, we need to actually look up into the storage array. So storage corners I, and then storage corners I plus 1, and again we have to cycle around. So we have to do modulo 6. So we won't get any overflow errors. And again, this basically means that when I equals 6, it needs to go back to 0. Okay, so hopefully if all this logic is correct, the mesh will look exactly the same, but it'll have a lot less vertices. Okay, that's not what I wanted to see. Okay, so let's look. Okay, it still has a lot of vertices and triangles, but it looks like, oops, I wanted to move this up. It looks like everything is like in a line. That's a little weird. I guess we could just print out the corner array. Doug log string format. Let's see. Cell number, and then we'll print out the corners here. So 1, 2, 4, 5, 6. There's got to be a better way to do it. Well, I know there is a better way with string builder, but this is a little easier to do quickly. So let's bring this down. 1, 2, 3, 4, 5, 6. Okay. So now we should get a big list of the corners for every single hexagon. And we can try and look and see if the pattern is what we expect. Okay, so obviously cell 0 should have 1, 2, 3, 4, 5, 6, and then cell 1 should, okay, so 7 is the center, so that's why it's not showing up, but then it creates these to 8, 9, 10, and it creates 11 because, again, it's on the first row, so it doesn't have anything below it, so it creates another 11, and then here it should take corner 2 from the one to the right, so it should be 0, 1, 2, 3, and that's correct, and then 1 and 2. So let's look at cell 6 because that's the first one. Oh wait, no, cell 5 is the first one on the next row, and that makes the first 3, and then it takes 2, which is should be vertex 1 from the one below it, which is right here. Again, remember that it's 0 indexed, so. And then it takes vertex, our corner 0, which is 1, and then it creates the next one. So yeah, everything looks good. So how come the mesh is not showing up? Maybe the vertices aren't positioned correctly? Okay, well here's the mess up. This should be a 2 right there. Would that cause everything to collapse? Okay, nope, still nothing. This still looks like a line. It's a little strange. And we still add the vertice there, and it's counting up correctly. I guess maybe the triangles are wrong. Okay, might as well try it. Debug log, string format, triangle. It's gonna spam our debug log a ton, but okay, so yeah, the triangles aren't weird or anything. Let's go to the first one. Okay, so 0, 1, 2, 0, 2, 3, 0, 3, 4, 4, 5, and 5, 6, and then 6, 1. So yeah, it starts at 0 because that's the center, and then it goes every pair. So yeah, nothing weird there. So that means that, I guess, the position is weird. So I guess that's the last thing to try out. Guess we can get rid of that because we know that's working. Oh, okay. Oh yeah, I typed vector 2 there. And Unity automatically converts a vector 3 to a vector 2, which is usually kind of useful, but not when you make a typo like that. So basically it was losing the z coordinate, which is why it showed up as a line in the terrain mesh. Okay, and now it's working. And I don't see any holes, so everything went according to plan, and now every mesh is, or every hexagon is sharing corners that are touching. Okay, so I think we've completed the flat grid, so next we gotta do elevations. And yeah, elevation is definitely going to complicate things quite a bit, because now we have to check if, before we share any of these corners, if a vertice or the hexagon has to be on the same layer. But I guess first we need to actually generate a map with multiple layers. For now, let's just make maybe the center block be on the second row. So port generator, get block. This would be 2, 2, 2. Oh wait, no, it'd be 3 in Lua index. And then we just set the prototype to dirt, which means it's not air basically, which makes it show up. I think now nothing will happen because the game doesn't care about elevation. Oop, actually, oh yeah, block out of bounds because I need to set 2 layers. Yeah, so right now the game just completely ignores it, even though this hexagon in the middle should be raised up. Although the graphics, I mean the blueprint builder, yeah, it does take elevation into account. Why don't we go ahead and just see if this is printing out values that make sense. String format, and we'll just do the column, so it's on a 0. Row and the elevation. Okay, well I'm going to be a little inefficient now and just call this function again. So what we should see is that the cell at column 2 and row 2 should have an elevation higher than the rest. Oh yeah, this, we can comment that code out. Okay, so yeah, they're all at 0, 0, 0. Okay, here it's at 1, so that's working good. Let's get rid of that code. Okay, so now that we know that the surface finder is correctly finding the higher elevation, we can start handling it here. So the elevation is in the blueprint. So let's go ahead and grab that data out. Oh, that was the right cost I wanted. Let's go back here. Equals blueprint. Oops. Cells index. Okay, so now the center is perhaps higher. So do the blueprint cell elevation. Let's just look at this. We should get a bump in the middle because the center will be higher than the rest. Actually, it might look a little weird, but we'll see. No, we don't. Oh, I think that's because the elevation step is 0. We got this height step. So the blueprint builder needs to set that. So I think actually the center and then the leading vertices that are always created will be higher than the rest. Yeah, which is weird. Yeah, so the center is just sticking up. Oh wait, no, this is the center right here. Did that just expose a bug? Okay, I'm not sure. Oh, we can't look at it that way. So this should be the center. Oh, well no, this is fine. And then it created those two. But why did this mesh not share its vertice? Because it should have... Actually, we can see two instances of vertices not being shared right there and right there. So it seems like... is a problem. Oh, here, yeah, because this vertice can actually be already created by the cell below us. Okay, so what is this? This is column +1 and row -1. So yeah, actually for vertice 2 we need to see if we're on. And yeah, here too as well. Okay, so what is this? This is vertice 5. Yeah, so vertice 2 if we're on, since we're +1, we have to make sure that the column is not the rightmost, and also that we're above the 0th row. Okay, so that was actually good practice because we caught that. Okay, so if column is less than the row size, oops, just the blueprint, and row is greater than 0, then storage corners 2 equals, what is it? Cell vertices, so it's our index plus 1 because it's a column over but also a row below us. And what's the number? 5, I think, the last one. Oh no, the 0 first. Okay, so let's see. This should fix one of the problems, but we also, I think, will need to edit this one a little bit and add one more possibility. Or did that fix it all? Well, it did, but I know that there's one other problem. So if we're at column, let's see. Is there any time that this vertice... Okay, no, actually that can't exist. I was thinking that we might need to check this hexagon for its corner 5, but I think if this hexagon ever exists, then this one definitely exists. Yeah. Okay, so yeah, we're good, I think. Yeah, because that would... Right, because this is our same column, so if this one existed but this one didn't, then we would have to be column -1, which is never, obviously doesn't exist, so yeah, we're fine. I feel like I need to comment this code, but it's really not going to be helpful. I think it'd be nice if I could somehow link to this image. Anyway, okay, so now we've got basic elevation, but it's not looking too nice. But it's kind of like, we obviously want everything to blend together, but I need to I think I just need to disable this canvas so I can actually see what I'm doing. So here's the center right here, and these 3 vertices should also be risen, but they're not because we share the one before us. So what I need to do, actually, for now, I just need to make it so that anything, if the terrain elevations don't match, then they can't share vertices, or can't share corners. Because later on, we'll need to create other triangles to bridge them together as some kind of ramp. Okay, so let's extract this because it's getting kind of big. Extract method, get, let's call it figure corners. I don't really need to keep all of this, or pass all this. really easy. I mean, this is just an array lookup, so no reason to pass that either. Okay, so now we just pass the index in the center. Okay, so again, we won't look here. How do I want to do this? I think the easiest way would be if we say, create another function here. Void. This code is going to get a little convoluted because we'd want to insert this corner in here, but otherwise we need to create it. So I'm trying to think of the best, because what I'm going to try and do is I was going to have a function that would like only return this, will return true or false if this corner was on the same elevation. But I'm going to have to do like a double lookup. I guess it's not that big of a deal, but and then this one is like a special case because it has 3 checks. So I'm not sure if there's going to be a really pretty way to do it. Maybe. Okay, so we always know that none of the corners is going to be vertex 0, so maybe one way I can do it. I equals 0, I less than 6. If storage corners I is 0, that means it hasn't been set, so we can just add vertex. Okay, so that means I can take away almost all of this type of code. Okay, so that's nice. And then private get same elevation corner. So we'd want to pass my elevation, and then other index and other corner index, and we return the corner. So if cell vertices other index. Okay, actually we don't have. We need to call the blueprint. So blueprint cells other index dot elevation equals my elevation. Then we return cell vertices for the other cell. Okay, and then if they have different elevations, then we'd return 0. To signify that we just need to create this vertex ourselves. Okay, so now I can just call get same elevation. Equals blueprint cells index dot elevation. Okay, and then I just pass that index, and then we need the corner. Oops, only one comma needed. Okay, now this code I think will work fine, and it looks okay. Need to replace the square bracket with a parenthesis. Okay, so let's look and see. I guess I should turn back on this to make sure that the vertices are still sharing correctly. Oops. first let's see if it looks right, and it does. Yeah, so the one hexagon, oh, it's hard to see because they're both green, but you can see a little better here, I guess. So this hexagon is higher than the others because it's a different elevation and it doesn't share any vertices. So let's look in the debug to make sure that everything else is still sharing vertices. Yeah, 3, 2. Okay, yeah, so everything looks good. Cell 5. Okay, so I don't think I introduced any bugs. So obviously we need to connect these vertices somehow. For now, I'm just going to draw more triangles to fill each of these squares, but at some point we'll want to make this obviously look a lot nicer by having slopes, but we'll get to that. Yeah, with better cliffs. But I will join these up, so that will be next thing, but unfortunately I'm out of time, so we'll have to continue this tomorrow. But I feel like we got quite a bit of work done. Oh, what's going on here? I just noticed. So this is the very last column. So right here, it's not creating that triangle. So let's look, what array would that be? Or what cell would that be? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to hide this canvas. Okay, so cell 9, 41, 42, 28, 24, 23, and 39. So the triangle that's missing is actually these two, so that's corners. Well, I think actually corner 2 is wrong because every other corner is there. So that was 9, right? So corner 2 is 28. So obviously I just did the code wrong somewhere, but so okay, so this is the very last. I think it must be this code that I did recently. Look here, I need to make sure that the column, I thought I made sure that the column wasn't the last, but yeah, if column is less than the row size. Oh, yeah, it should be less than row size minus 1. Okay, so let's make sure that this works now. Okay, there we go. Back to normal. Not missing any other triangles anywhere, I don't think. Alright. Okay, but now I really do have to go, so again, thanks everybody for coming by and watching. I do appreciate it. I'll be back tomorrow around 8:30 Eastern, and we'll continue from where I left off. Connect up these cliffs, and what will be next? Oh yeah, mouse picking. So that's when we'll need to make the physics mesh collider so that we can try and find out where a raycast actually hits this, and then we'll figure out which hexagon and everything. And then we'll get into some more graphics. We'll try and have different colors and they'll blend together using a nice shader. So that will be pretty fun. But anyway, if you missed this stream or any others, I do have a YouTube channel. You can get to it from !YouTube and chat, or from my channel description. I also have a Discord channel if you want to chat with me and other viewers. I'd really love to have you because we have a pretty small community right now, so it'd be nice to have other people to talk to. But you can get there from !Discord and chat, or again from my channel or video description. And of course you can follow me here on Twitch to be notified when I go live tomorrow, like I said, around 8:30 Eastern. And I hope you all have a great night. Again, thanks for watching. Bye bye.